welcome in the second part of pH sensor. So in first part, I explain you how to what is the theory behind the pH sensor, how pH sensor works, and in this part, I'm going to show you how to calibrate this thing because we are going to interface this with our microcontroller. So first of all, we have to calibrate the sensor, right? Because sensor is not calibrated right now. So we have three different buffer, and we will going to calibrate this. So let us see first of all the setup.
So here you can see I have made three different buffer. One is with 4.0 pH, one is with 6.86, and one is with 9.18. Okay, I will also show you how I made this buffer. So basically these are the 250 ml distilled water sample, and I have just added these buffer powders purchased from the online store, and this is how I made it. So in today's video we will going to calibrate our pH sensor. Okay, and once we have the calibrated program available with us, we can measure the pH of our any water or any liquid. So this is the setup. You can see this is the sensor. I will show you. This is the sensor, right? You can see, and I just put it in distilled water. So this last glass is of distilled water, this one. Okay, and these three samples, and you can see this sensor is connected with this board, and here on LCD you can see the display, right? This is for the display. So this is overall setup.
So now let us see the code. So this is the same code which I have explained you in data logger part or data logger video. Now here I'm just adding two functions because now we are not going to do anything with the data logger or the sensor. This video is totally for the pH sensor. So we have two functions. You can see here one function is display voltage for calibration and second function is display pH with calibration. So basically in calibration, what we have to do, we have to have some sample voltages, right? Let us say for pH 9.18, we have X voltage, and pH 4.0, we have Y voltage, right? So basically we have to measure these two reference voltages for our specific setup only, right? Because this sensor is connected with our board, so we have to calibrate this sensor in current condition. So that is what we are going to do. So this function is basically only and only display the voltages. So whenever you put your sensor in particular liquid, this setup or this program will simply read that voltage, convert into digital, convert into voltage, and display on LCD. So you can simply record it, right? So this is what our goal is. And second is, after reading all these values, we will going to write slope equation and we will do further processing. But for that we have to have some sample voltage, right? So now let us understand this function first. So this display voltage for calibration function is start with simply reading analog signal, converting this analog into digital, and convert the digital value into voltage, right? So this is what this function will do. Here you can see simply display messages for UART, this display for LCD, pH calibration, voltage mode, and here you can see this conversion start. So our sensor is connected with ADC 3 pin, so that's why you can see our channel number 3 is configured, right? And here we are taking 30 sample and averaging them because as I told you earlier, in other two sensor also we did the same thing because our output is fluctuated a lot. So we have to take a sample, we have to take an average so that we have some stability, right? That is why we are sampling this. So again, in this sampling, you can see same ADC pole conversion. Whenever ADC value is ready, we are just reading that value, okay, adding in some, and then finally divide by 30. So this is our average ADC value of 30 sample, right? Now after this, what we are trying to do, we are simply converting this into milliwatt, right? And here in these two part, you can see in first this terms of code, we are simply displaying ADC value on first line of LCD. So 80 means first line of LCD. We are simply displaying ADC value. So it's a digital value after converting analog voltage into digital. And on second line, we are displaying voltages, right? We are displaying voltages as it is, right? So now I'm compiling the code, and when I will run this code, you can see this is again in while one loop. So infinite time it will simply display voltage continuously. So whenever you will put that sensor in whatever liquid, it will simply, microcontroller will read that value, convert into voltage and display it. That's it. And this thing required because we have to have two samples. We need two value, one for 9 pH and one for 4 pH. Right? Once we have these two voltages, we can write our slope finding functions, and then we can have formula to convert any analog voltage into equivalent pH. So this is for calibration part, and now I'm loading the code, and next we will see the calibration part.
So here you can see we have some voltage ADC, right? Now let us remove this sensor from distilled water and let us put it in 4.0 buffer. Okay, and now let us record this. It will change, but let us just record this after 10 or 20 seconds. And you can see for 4.0 we have 2.926 something, right? So let us just write down for 4 2.92. okay, now let us change this. So before changing, you have to just wash this, or you have to clean the previous value. So I'm just moving it in the distilled water, and now let us put it in 9.18 buffer. This is 9.18 pH value buffer, and now let us measure the voltage, and you can see voltage changes. So now this time we have 2.10. So for 9.18 we have 2.11. okay, so this is pH and this is voltage. So now we have two different values, you can say, right? And here you can see this is the voltage, right? So now we have just measured these two voltage using display voltage function. Okay,
so now we have 2 points, okay, one for 9.15 pH one voltage, and one for 4 pH another voltage. So now basically what we will going to do, in calibration part we have these two value. Now we will going to write a function to find the slope of the line, because let us say these 2 points are there, and assume that all other points are also located on this line only, right? Because some linearity is there. For each pH, some fixed type of voltage changes will be there. So if we have the slope of this line, then using simply y is equal to mx plus c function, we can have the pH value for that particular voltage. Okay, so to find the slope, you have to simply find y2 minus y1, this 950 minus 4, and 211 minus 2.92, and that will be your slope. Okay, and let us say we have another one, intercept is there, right? Which could be any value. So now if we have the c, and if we have the mx plus c, right? So now m is your slope, c is your intercept. Then in future, whenever you put your sensor in any liquid, you will have some voltage, and if you will put that voltage in place of x, you will get the y, which is actually pH value. So this is what about the next function, right? So I'm going to explain you this next function in next video. So till then, if you like my work, please like my YouTube videos, subscribe my channel, share it with your friend. Till then, bye bye. Thanks a lot for watching this video.